Today we are going back to the mole. Remember what a mole is for. Chemists use the mole to count really small things like atoms. Remember, you can't see one single atom, but we can see 6.02 times 10 to the 23 atoms. The mole is a unit that the chemists use so that we are able to use it and see it when we are doing experiments in the lab. Well, today we are going to review Avogadro's number, which is 6.02 times 10 to the 23. But today's focus will be on molar mass, the mass of 1 mole of a substance. Let's take a look at these pictures. In the image to the right, you have a dozen eggs, a dozen roses, and a dozen donuts. Well, what is a dozen? How many of each item do you have? Right, you have 12. You have 12 eggs, 12 donuts, 12 roses. That's what a dozen means. Well, would a dozen of each object have the same mass? In other words, would they weigh the same? No, they wouldn't. You know that the dozen donuts is probably lighter than the dozen eggs and the dozen roses. So then let's talk about chemistry. Suppose you have a dozen carbon atoms, a dozen gold atoms, and a dozen iron atoms. Even though you have the same number of each, would you expect them all to have the same mass? If you said no, you're correct. They're all different substances. So when counting roses, eggs, or donuts, a dozen is a good unit to use. But if you're counting atoms, a dozen doesn't help much at all, right? Since atoms are so tiny, we use a unit called the mole. A mole represents a macroscopic quantity of matter that can be used in the lab. 1 mole of any element has the same mass in grams as its atomic mass in AMU. Now remember, we learned that in the beginning of the year. We learned about average atomic mass. How did we determine the average atomic mass? For example, what is the average mass of a gold atom? You look at the periodic table, you find gold, and there you have the mass. We learned that previously as the average atomic mass. So in this case, gold's average mass is 196.967 AMU. Well, we're not talking about average atomic mass anymore because we're not talking about one single atom of gold, but now we're talking about 1 mole of gold. We want to know what the mass is in grams of 1 mole of gold. And when we say 1 mole of gold, remember that we're talking about 6.02 times 10 to the 23 atoms of gold. That is 1 mole. So the mass is actually the same thing as the average atomic mass, 196.967 grams of gold is equal to 1 mole of gold. While the number of atoms in a mole is constant, the number of grams in a mole changes based on the element. So for example, take these 3 elements here, sulfur, copper, and carbon. 1 mole of sulfur is equal to 6.02 times 10 to the 23 atoms. 1 mole of copper is equal to 6.02 times 10 to the 23 atoms. 1 mole of carbon is equal to 6.02 times 10 to the 23 atoms. So the number of atoms in a mole is constant, but the mass is different. The number of grams in a mole is known as its molar mass. The units are grams per mole. That many grams equal to 1 mole. And it has the same numerical value as an element's atomic mass, which we learned previously as the average atomic mass with the units of AMU. Using your periodic table, we're going to determine the mass of 1 mole of each of these substances. So find sulfur on your periodic table. 1 mole of sulfur has a mass of 32.06 AMU. Therefore, the molar mass is 32.06 grams per mole. So the molar mass is the mass of the substance that is equal to 1 mole of that substance. So when we write grams per mole, This is actually saying that there are 32.06 grams that's equal to 1 mole of sulfur. Okay, so grams per mole. Now sometimes the masses on your periodic table will have 5, 6, 7 numbers. So that we are consistent, we're going to round the masses from the periodic table to the 100th decimal place, so the second place after the decimal. Okay, so 1 mole of copper, according to our periodic table, is 63.546. I'm going to take that number to the 100th place. If I need to round up, you're going to round up. So copper has a mass of 63.55 AMU. Therefore, the molar mass is 63.55 grams per mole. Go ahead and find carbon. Round the mass to the 100th place. Carbon has a mass of 12.01 AMU. Therefore, the molar mass is 12.01 grams per mole. Now, what if we have a compound? Like, for example, iron 2 chloride, FeCl2. Well, you have to consider the number of atoms of each element within that substance. So for iron 2 chloride, how many iron atoms do we have in FeCl2? We have 1. How about chlorine atoms? We have 2. What is the mass of 1 iron atom? Remember that you need to look at your periodic table to find iron's mass. Iron has a mass of 55.85 grams per mole. Well, what about chlorine? Chlorine, for just 1 chlorine, has a mass of 35.45 grams per mole. So let's find the sum of their masses. Now keep in mind that there's 1 iron atom and 2 chlorine atoms. So we're going to add up 55.85 plus 35.45 times 2 because of the 2 chlorine atoms. So what do you get for the molar mass of FeCl2? You should have gotten 126.75 grams per mole. Go ahead and pause the video here and determine the molar mass of 1 mole of each of these substances. Make sure you use proper units. Did you get these molar masses? We should all have the same answers. Your answer should be to the 100th place. Remember that we're all using the same periodic table. Your numbers should not be different from my numbers. Now we're going to go over one more type of substance, which is called a hydrate. A hydrate means a substance with water. As you can see in the picture, it's a crystal-like substance. It is not a liquid substance, even though it has water in the name. It really just means that there are water crystals that are attached to this ionic substance. So for example, for sodium sulfide, there are 9 molecules of water that are attached to this sodium sulfide compound. So when you calculate the molar mass, you simply add the 9 molecules of water to the mass of the sodium sulfide. So you figure out the molar mass of sodium sulfide, you figure out the mass of water, and you want to multiply the mass of water by 9 because there are 9 water molecules, and then you just add them up. So go ahead and pause the video here to take the time to figure out the molar mass. Play the video when you're ready to check your answer. So for sodium sulfide, I got a molar mass of 78.04 grams per mole, and water has a mass of 18.02 grams per mole. So the mass of water is 162.18 grams per mole, which gives this a total mass of 240.22 grams per mole. So what do we do with molar mass? We use the molar mass to convert moles to grams. In a lab, when we're doing experiments, there's no way to measure a mole, but there are ways to measure grams, and that's the mass. And so previously we learned the conversion factor that 1 mole is equal to 6.02 times 10 to the 23 particles. And there were different words for particles, right? Atoms, molecules, ions, formula units. They all meant the same thing when it came to particles that are equal to a mole. Well, now that we learned about covalent substances and ionic compounds, the word molecule is used for covalent substances, and the word formula units are used for ionic compounds. And you guys know by now what atoms are and ions are, and particle is a general term for any of these substances. And then now the second conversion factor you guys know about is that 1 mole is equal to grams, mass of a substance. And that is known as molar mass. We get that by using the periodic table. So let's take a look at some of these practice problems, and we're going to convert between these units. So let's take a look at some practice problems. You're going to set up the problem using the fence, otherwise known as dimensional analysis, and then solve. Remember to use proper units and consider significant digits. So the first one, how many moles are in 9.15 times 10 to the 26 formula units of aluminum chloride? Now, for each of these problems, ask yourself, what are you given and what do you need to find? So in this case, you are given formula units and you are asked to find the number of moles. So we're actually going to draft out our fence first. This will help you as you go through each practice problem, especially when you need to set up multiple fences. So we are given formula units of aluminum chloride. And remember in the diagram that I showed you, or the picture that I showed you previously, what was always in the middle? You always have moles in the middle, right? So no matter what unit you're given, you always have to go through moles. And for this problem, it's simple because you are given formula units and you are asked to find moles. So there is our path. So we replace this arrow with a fence, and this shows you that you only need to set up one fence. And then what do we do diagonally? We copy down the units, so in this case formula units of aluminum chloride. So in our second fence, you'll notice that you have moles on top and formula units on the bottom. Remember that this is a conversion factor or a ratio that we talked about previously. How many moles is equal to how many formula units? You have 1 mole is equal to 6.02 times 10 to the 23 formula units. Do you remember where the numbers go? So say it out loud again. 1 mole is equal to 6.02 times 10 to the 23 formula units. So we put 1 next to mole, 6.02 times 10 to 23 next to formula units. You know that your diagonal units will cancel out. And then you multiply across, divide by whatever's on the bottom, and the answer you get is 1.52 times 10 to the 3 moles of aluminum chloride. So this has 3 significant digits because your starting number, your given number, has 3 significant digits. And if you're wondering if this had to be in scientific notation, it did not have to be. I just find it easier to put numbers in scientific notation, especially when we're dealing with significant digits. Okay, so the next question, what is the mass of 10.0 moles of sulfur? So again, think about what you're given, moles, and they want mass. Remember the unit for mass is grams. So given moles, we're trying to find grams. We're going to replace that arrow using the fence, and then what do you do next? You copy down the unit, so we bring down moles. So you'll notice that whenever you think about what you're given and where you're trying to go or what you're trying to find, the top fence is already set up for you. In fact, the top fence is what students find the most difficult. And so if you think about what you're given, where you're trying to go, and you put that down and you replace the arrows, not that you have to draw the arrows, but it's a good visualization, and you replace the arrows with the fences, that tells you exactly how many fences you're going to use. And again, you'll see how handy it is as we go throughout our problems and we have to deal with more fences. So now here, the conversion factor we're looking at is grams over moles. Remember what that is. That's molar mass. So you look at the periodic table, you need to find sulfur, round it to the 100th place, and you get 32.06 grams per mole. So we write 32.06 on top next to grams and 1 next to moles. Our moles cancels out. We multiply across, divide by whatever's on the bottom, and you get an answer of 321 grams of sulfur, and this is to 3 significant digits. I'm going to pause here and say I know that I'm not giving you a lot of time to calculate it yourself, so make sure that you are pausing the video periodically and trying out these problems on your own as well. Like you're practicing putting in these numbers into your calculator, and the answer that you get in your calculator is matching up with my answers. So go ahead and try the next problem on your own. How many moles are in 27.4 grams of copper 1 oxide? Go ahead and play the video when you're ready to check your work. So this is what your setup should look like. Starting with 27.4 grams of copper 1 oxide, you're trying to get 2 moles of copper 1 oxide, so you copy down the unit, grams goes on the bottom, the molar mass is 143.10 grams per mole. This time you are dividing the two numbers and you get an answer of 0.191 moles of copper 1 oxide. Let's take a look at the next one. How many formula units are in 66 grams of sodium sulfide hydrate? So you are given grams of sodium sulfide hydrate and it's asking for formula units. So given grams, we need to find formula units, but remember we can't go straight from grams to formula units. Remember the diagram that we went over in our notes? What is always in the middle? We have to always go through the mole. So from grams, we go to the mole, and then we can find formula units of this hydrate. So we replace those arrows with fences, and here you can see that we're dealing with 2 fences. Diagonally, we're going to go ahead and copy down the unit, and now we're going to fill it in with our numbers. So in our second fence, we have moles over grams. You need to recognize that that is molar mass. And we found the molar mass of this hydrate previously. We have a molar mass of 240.22 grams per mole. So where do those numbers go? 240.22 will go on the bottom next to the unit grams. 1 goes on top. Let's complete our next fence. Formula units over mole. Well, what numbers are going to go there? What is the conversion factor that we're using here? 1 mole is equal to 6.02 times 10 to the 23 formula units. So 1 goes next to mole. 6.02 times 10 to the 23 will go next to formula units. Our grams cancels out, our moles cancels out. You multiply across 66 times 1 times 6.02 times 10 to the 23 divided by 240.22, and you get an answer of 1.7 times 10 to the 23 formula units of the sodium sulfide hydrate. How many oxygen atoms are in 8.47 grams of nickel 2 nitrate? You are given grams of nickel 2 nitrate, and this problem is asking for oxygen atoms. So given grams of nickel 2 nitrate, where are we going to go next? We're going to go to moles of nickel 2 nitrate, right? We have to go through the mole. Now what's next? If you thought that we're going straight into oxygen atoms, that's actually incorrect. you can go to formula units of nickel 2 nitrate next. Think about the substance. Look at the formula. This is an ionic compound. Those oxygen atoms are within this compound. So you need to look at the general compound first. And because this is ionic, we call it formula units. And then you can talk about the oxygen atoms. So here's our general path. We're going to go ahead and replace those arrows with the fences. So now you see that we have 4 fences. Go ahead and copy down the units. And now let's fill in each conversion factor. Moles over grams, you know that that is molar mass. The molar mass for nickel 2 nitrate is 182.71 grams per mole. So next to grams, we're going to write 182.71 equals 1 mole. In 1 mole, there's 6.02 times 10 to the 23 formula units. And within that one formula unit of nickel 2 nitrate, so within that one compound, how many oxygen atoms do we have? 3 times 2 is 6. We have 6 oxygen atoms. So multiply across, divide by the numbers on the bottom, and you should get an answer of 1.67 times 10 to the 23 oxygen atoms. Pause the video here and try the nitrate ions. Play the video when you're ready to check your answer. So this setup is similar to our previous problem. Given grams of nickel 2 nitrate, you go to moles of nickel 2 nitrate. You have to go into formula units of nickel 2 nitrate first, and then you can figure out the nitrate ions. So again, we have 4 fences, copy down the units, and then fill it in. So the molar mass is the same because we're dealing with the same substance as the previous problem. 1 mole is equal to 6.02 times 10 to the 23 formula units. And in one formula unit of nickel 2 nitrate, how many nitrate ions do we have? Did you say 2? Right, you have 2 nitrate ions. So you multiply and divide, and you should have gotten the answer 1.483 times 10 to the 23 nitrate ions.